Today we are going to start Unit 30, Isomerism. So in this unit we are going to learn what is isomer, and we are going to learn two main types of isomerism, and we are going to learn how to identify different types of isomerism and what kind of properties they have. To begin this unit, let's answer this question. What is isomer? So isomers are different compounds that have the same molecular formula, but they have different linkages of atoms or spatial orientations of atoms. Here we got an example. Okay, so if we have a molecule with C3H8 and O as a molecular formula, there are three possible structures we can draw for this molecule. Okay, so here it draw the three possible structures for these molecular formula. So we call them isomers. So in this chapter, we're going to discuss two main types of isomerism: structural isomerism and also stereoisomerism. So in this lesson, we're going to learn the first type, structural isomerism. So for structural isomers, atoms are bonded into different order. Okay, just like the sample we have seen, okay, we can place the O in at different position and make it into a different molecule. So for structural isomerism, we have three subgroups, okay? Chain isomerism, position isomerism, and functional group isomerism. Okay, so let's look at it one by one. The first type is called chain isomers. So for chain isomers, just like indicated in the name, of course, they are different in the carbon skeletons, so the longest carbon chain. But you need to also note that they must have the same functional groups. Okay, here we got an example. On the left hand side, we have butane, which got 4 carbons in a row in the longest to form the longest carbon chain. On the right hand side, we got methylpropane. So the longest carbon chain only got 3 carbons in it, and we have one methyl group as the branch. Both of them have 4 carbons in it, and both of them have a formula, molecular formula as C4H10. Okay, so they are called chain isomers. So let's try this checkpoint question together. Try to draw all the possible chain isomers of C5H12. Okay, so remember, in order to be chain isomers, they must all have the same functional group. And if they have a formula like this, we will be able to identify that they are alkanes. So let's draw it out. The first possible way is always the easy way, just draw a linear molecule. Okay. And then fill in all the hydrogens attached to the carbon. Okay, that's the first possible way to draw it. And then we can move one of the methyl group to a branched position. So that will give us the second possible way to arrange those atoms. Okay, so here, let's put one of the methyl group here. Okay, so for this molecule, again, the molecular formula can be C5H12, but we got one methyl group at the branch. Okay, so it's a chain isomer to the first molecule. And then we can further remove one of the branch, okay, in the end, and then attach it to the second one. So that will give us this molecule. Okay, so for this one, again we got 5 carbons in total, and we also have 12 hydrogens, so that's a different way to arrange those atoms, and it's still alkane, so that's the chain isomer of the previous 2 molecules. So that's the first type we're going to discuss. And then the second type we got was called position isomer. So in order to be position isomers, they must have the same carbon skeleton and functional group, but the position of the functional group need to be different. Okay, here we got an example. On the left hand side, we got propane 1O. That means the OH group is attached to the first carbon. And then on the right hand side, we got propane 2O. That means hydroxide group is attached to the second carbon, so in the middle of the carbon chain. So the position of the functional group differs, okay, at position 1 and at position 2. Okay, so we name them as position isomers. Let's try some more example together. Draw and give the IUPAC name of all the position isomers of C3H7I. Okay, so let's draw the carbon skeleton. Remember, they need to have the same carbon skeleton and same functional group. So here we have one iodine attached to the to this molecule, so it will be an haloalkane. So the first way to draw it is to draw the iodine attached to the carbon at the front, and then we also need to fill in those hydrogen attached to the carbon chain. Okay, so for this one, we will name it as 1-iodo, and because it got 3 carbons in the longest chain, then we should call it propane. And then we can move this iodine to a different position, so not at the end of the carbon chain but in the middle, and that will give us a position isomer. Okay, also fill in the hydrogen. So for this molecule, because the iodine now attached to the second carbon in the carbon chain, so we call it 2-iodo propane. So that's the second type. And the third type we got was called a functional group isomer. So for functional group isomers, they have the same molecular formula, but they contain different functional groups. So here, an example. So on the left hand side, we got the carbonyl group attached at the end, so that's a propanol. But on the right hand side, we have the carbonyl group attached in the middle of the carbon chain, so that's in propanol. Okay, so they got different functional group, but again, same molecular formula. Okay, let's take a look at this example, checkpoint question. Draw a functional group isomers of propanoic acid and name the compound. For propanoic acid, the molecular formula should be C2H5 and COOH. Okay, so now how can we rearrange those atoms and put them in a different way so that it got a different functional group? So the only type of molecule that we have learned with 2 oxygen in it from last unit is an ester. So let's try to draw the possible ester. So first, let's have a methyl group, and then attached to one of the oxygen, and then another carbon double bonded to the oxygen. Remember, for propanoic acid, it has 3 carbons in total. So for the molecule we're going to draw, it must have 3 carbons as well. And then we fill in the hydrogen. Okay, now we got the ester, and how do we name this? Okay, again, from last unit, we know we separate from here. So on the left hand side, it comes from an alcohol molecule. On the right hand side, it comes from a carboxylic molecule. Okay, so the first part we got is from methanol. So we change the ending, that will become a methyl. On the right hand side, we got ethanoic acid. So we change the ending, it will become ethanoate. Okay. Okay, so now let's check what we have learned so far. So identify the following pairs of compounds as chain isomers, position isomers, functional group isomers, or identical compounds. So here I label these 4 answers with numbers, so it will be quicker for me to write the answer. Let's take a look for part A. Okay, so you can highlight the functional group. For the first one is for the first one, the functional group is the hydroxide group. But for the second molecule, we got a single bond O to another alkyl group. Okay, so they got different functional groups, so it should be a functional group isomers. Okay, and for the second one, they have same molecular formula. However, you can see the longest carbon chain, okay, is different. On the left hand side, we have 6 carbons forming the cycloalkane. On the right hand side, we have only 5 carbons forming the cycloalkane. Right, so they should be chain isomers. Okay, for C, take a look. Both molecules have 5 carbons in the longest carbon chain. And the way that we represent it is just a different way of representing organic molecules. So, they are actually identical compounds. Okay, so why we draw it like this? Remember, we have learned the structure. So actually for this one, if we draw it in a 3D way, you will see that the carbon chain is actually going up and down, up and down. Okay, but for simplify, we can draw it as a linear molecule. Okay, then for the next one. Okay, so they look different. Okay, if it just presented by this way, they look different. However, if we do something to the right hand side molecule, okay, let me get a copy of this molecule. Okay, now I have a copy of the molecule on the right hand side. Okay, let's rotate this molecule. Okay, rotate it. And then, okay, let's compare. After the rotation, it changes to the same molecule as the one presented on the left hand side. So actually, they are identical molecules. Okay, so let me do it again for you. If I rotate it, it becomes the molecules on the right hand side. So they are identical molecules. Okay, next one. Okay, next one. First, they have same functional group. Okay, both of them have OH group attached to it. But on the left hand side, the OH group is attached to the first carbon. On the right hand side, the OH group is attached to the second group. Okay, so they have same molecular formula, they have same functional group, but the functional group is placed at different position, so they are position isomers. Next one. Okay, so now for both of the molecule we have 2 carbons, and we also have 2 bromine attached to the carbon chain. Okay, and let's take a look at the position of those 2 bromine. One of the bromine is attached to the first carbon, the other bromine is attached to the second carbon. On the right hand side molecule, again, one of the bromine is attached to the first carbon, the other bromine is attached to the second carbon. And in later lesson, you will know that actually the carbon-carbon single bond can be rotated. So if we rotate along this bond, it will become the molecule on the left-hand side. So they are actually the same molecule, identical molecules. Okay? Because the two bromine are attached to the same position of the carbons. Next one. Okay, so again here we have bromine attached to the alkane, so it's a haloalkane. And then let's work out the longest carbon chain. On the left hand side, let's try to label it 1, 2, 3. That's the longest carbon chain, and then we got 2 methyl groups attached to the carbon chain. On the right hand side, again, let's find out the longest carbon chain. 1, 2, 3, 4. Okay, and then we have 1 methyl group attached to it. Okay, so here you can see they have the same molecular formula and they have same functional group, but the carbon chain got a different arrangement, so it's classified as chain isomers. Okay, and for the last molecule, again, we can label the aromatic parts to try to work out are they identical molecules or not. So 1, 2, 3, 4, 5, 6. So you can see the methyl group is attached to the first one, and then followed by ethyl group attached to the second position, and finally a methyl group attached to the third position. So on the right hand side, again, we can label 1, 2, 3, 4, 5, 6. Okay, so again, the methyl group attached to the first position, same as the left hand side. And then we got an ethyl group attached to the second position, same on the left hand side. But here, the last methyl group is attached to the position 4. But on the right hand side, the methyl group is attached to position 3. Okay, so the carbon skeleton got a different arrangement, so it should be classified as the chain isomer.